Have you ever wondered what it would be like to travel in time, to change the past or witness the future? Time travel, a concept that has sparked human curiosity and imagination for ages, is a captivating enigma that we're about to unravel. So sit back and let's take a journey through the mysteries of time travel. From the earliest depictions in ancient myths to the intricate plots of modern science fiction, the idea of time travel has always held a special allure. It's a tantalizing thought, isn't it? The ability to leap through the ages, to witness history firsthand, or perhaps to get a glimpse of what's yet to come. Now you may wonder, is time travel just a product of our fertile imaginations, or does it have a basis in reality? Indeed, some of the greatest minds in science have grappled with this question. Theories that attempt to explain the nature of time and the possibility of traversing it are as fascinating as they are complex. One such theory is Einstein's relativity, which revolutionized our understanding of time. According to Einstein, time isn't constant, but relative. It can stretch or shrink depending on the gravity and velocity involved. Imagine that. It's a bit like a cosmic roller coaster ride where the track is time itself. Then there's the concept of wormholes. These hypothetical shortcuts through space-time could potentially be our portals to different eras. It's like taking a back door through time, skipping the long route and stepping straight into a different century. The enigma of time travel isn't just about the science, though. It's also about the paradoxes that come with it, the philosophical questions it raises. Like, if you went back in time and changed something, how would that affect your present and future? It's a mind-bending riddle, isn't it? Time travel, a captivating concept that has intrigued us for centuries, has its roots in some groundbreaking scientific theories. Yet, despite all our understanding and imagination, it remains an enigma. But who knows what the future may hold? After all, isn't that the allure of time travel? The thrill of the unknown, the promise of discovery? Albert Einstein, with his revolutionary theory of relativity, provided a scientific basis for the possibility of time travel. Now, let's dive into this concept. Einstein's theory of relativity is a game-changer, suggesting that time isn't a constant entity, but is relative and flexible. Imagine for a moment you're on a speeding train. According to Einstein, your watch would tick slower than the watch of a stationary observer. The faster you move, the slower time passes for you. This phenomenon, known as time dilation, lays the groundwork for the idea of time travel. But what about traveling to the past? That's where black holes come into play. These cosmic entities, born from the death of massive stars, possess gravitational pulls so strong that not even light can escape their grasp. They warp space-time around them, creating what is known as an event horizon. Now, this event horizon is a point of no return. Once an object crosses this boundary, it's inexorably drawn into the black hole. However, as theoretical physicist Kip Thorne postulates, if a sufficiently advanced civilization could stabilize a black hole, it might be possible to traverse the event horizon without being torn apart. This would lead us into the black hole's singularity, a point of infinite density where our current understanding of physics breaks down. Theorists suggest that singularities could serve as bridges to other points in spacetime, opening up potential pathways to the past or future. But here's the catch. The physics of black holes is still largely theoretical. We've yet to fully understand their mysteries, let alone figure out how to safely navigate them. Despite this, they remain a tantalizing prospect in our quest to master time travel. As we approach the event horizon of a black hole, time appears to slow down, potentially offering a portal to another era. So, while time travel remains in the realm of science fiction for now, the theories of relativity and the enigma of black holes provide us with a tantalizing glimpse into the exciting possibilities that may await us in the future. But as we delve deeper into the complexities of time travel, we encounter fascinating paradoxes. Let's take a step back and revisit our cosmic twin. This twin paradox raises an interesting conundrum. If time is relative, then who is to say which twin is truly older? From the perspective of the Earth-bound twin, the spacefaring sibling has aged less due to high-speed travel. However, from the perspective of our intrepid astronaut, the Earth-bound twin has aged less due to the immense gravity of the planet. Both perspectives are equally valid, creating a paradox that challenges our understanding of time and reality. But the paradoxes of time travel don't stop there. Let's journey further into the realm of the hypothetical and consider the infamous grandfather paradox. Imagine you built a time machine and traveled back to a time before your parents were born. Suppose you accidentally, or intentionally, prevent your grandfather from meeting your grandmother. Would you cease to exist? Or would you create an alternate timeline where you never existed, but you, the time traveler, continue to exist as an anomaly. These paradoxes are not just mind-bending puzzles. They challenge our understanding of causality, the principle that cause precedes effect. If you can travel back in time and change the past, then the effect precedes the cause, flipping our understanding of causality on its head. Moreover, these paradoxes question the concept of free will. If you can change the past, then is the future predetermined? Or does every decision create an alternate timeline, a new branch in the multiverse, where every possibility exists? The paradoxes of time travel challenge our understanding of reality and raise profound questions about causality and free will. They remind us that time is not just a simple progression of cause to effect, but a complex tapestry woven from the threads of possibility, choice, and existence. As we continue to explore the mysteries of the universe, these paradoxes serve as fascinating signposts, guiding us towards a deeper understanding of the nature of time and reality. Pop culture, with its imaginative storytelling, has embraced the concept of time travel, making it a popular theme in movies and books. From the lighthearted escapades in Back to the Future to the poignant temporal loops in Groundhog Day, time travel has been employed as a narrative device to explore themes of destiny, regret, and the human condition. It's also been used to pose intriguing philosophical questions, as in the mind-bending film Interstellar. The portrayal of time travel in pop culture has undeniably influenced our perceptions of it, shaping it as a tantalizing, albeit challenging, possibility. The idea of venturing into bygone eras or catching a glimpse of the future is enticing and fuels our collective curiosity. But we must remember, these are stories spun from the loom of creativity. Is time travel just a fantasy woven by imaginative storytellers? Or could it hold more truth than we currently comprehend? So, can we ever hope to travel in time? Theoretical physics might have some answers. While we may not be packing our bags for a vacation to the Cretaceous period just yet, the realm of theoretical physics presents interesting possibilities. One such concept is that of closed time-like curves, which are essentially loops in spacetime that could theoretically allow for time travel. If these exist, they could serve as cosmic shortcuts, enabling us to traverse vast temporal distances in the blink of an eye. Then there's the notion of wormholes, bridges through spacetime predicted by Einstein's theory of general relativity. If we could stabilize and navigate these passageways, they might offer a route not just to distant regions of the universe, but potentially to different points in time. However, it's crucial to remember that these concepts are largely theoretical. We haven't found a closed, time-like curve or a traversable wormhole yet, but the lack of empirical evidence doesn't mean we should dismiss the possibility. After all, science is as much about exploring the unknown as it is about explaining the known. Furthermore, the feasibility of time travel isn't just a question for physicists. It's a topic that spans multiple disciplines, from philosophy to computer science. For instance, if time travel were possible, how would we handle the paradoxes that could arise? Could we develop computational models to predict and circumvent these paradoxes? In the end, the question of time travel isn't just about whether we can do it. It's about how we would navigate the profound implications if we could. Our understanding of time and its potential manipulation is still in its infancy. As we dig deeper into the mysteries of the universe, who knows what we might discover? The possibility of time travel, while still a subject of conjecture, continues to intrigue scientists and laypeople alike. As we conclude our exploration of time travel, we are left with more questions than answers. From the mind-bending theories of Einstein's relativity and the potential existence of wormholes, to the paradoxes that challenge our understanding of reality, we've traversed the temporal landscape of this fascinating subject. We've seen how time travel has been embraced by pop culture, turning it into a narrative tool that both entertains and provokes thought. We've heard from experts in the field, discussing the theoretical possibilities that might one day turn science fiction into science fact. Yet, the enigma of time travel remains. It's a puzzle waiting to be solved by the curious minds of the future. The mysteries of time travel continue to elude us, sparking our imaginations and fueling our desire to understand the universe we inhabit. So, until we meet again, keep questioning, keep exploring, and remember, time waits for no one.